finishing up on question 6. We ended up with our slope, remember, was negative 1,400. Our intercept was 28,000. And that's the equation used to represent the draining of Allie's pool. And then the domain, if we looked at the graph, our domain went from 0 to 20. So it only took her 20 minutes. And our range went from 0 to 28,000. So as many people noticed, she started with more water, but it took her less time. So domain 0 to 20, range 0 to 28,000. Okay, and it's asking here, I want to point out something that it's asking here. It's asking you to compare the two. And then it says, compare the two domains by describing the constraints by the situation. The situation is the story. Okay, we always want to come back to the story because it's something to hook our brain on. The constraints of the story are how much water is in each pool. And the pump pumps obviously at a different rate. So that's a constraint, and it lets us know how many minutes are involved. So that's all they're asking you about there. All right, so it says for part 3, we're going to go back to this idea that they intersect. When do they intersect? When does A of x equal D of x? And what does this mean? Then they want us to find A of 5, and what does this mean? So we're putting a number in here for x. Then they want to ask, well, what if D of x equals 2,000? So that means 2,000 gallons. What is x going to be? And that's the time. And then somebody was talking about the fact that for part of the time, A of x is higher, and then for the rest of the time, A of x is lower. So we have to find an interval here. So this is going to be an interval. This is going to be an interval. Okay, this is going to be a point, okay, with xy coordinates. Here, we're going to take our rule. Let me put this down so we can see our rule. We're going to take our equation of negative 1,400 times the number plus 28,000, and we're going to say, well, what if x is 5? Let's do that one first. So what if it was 5 minutes? I just multiply this, negative 1,400 times 5, and add 28,000. Okay, and you can figure that out. I'm not going to give you the answer right now. Try to figure that out. I'm going to do it on my calculator when I do it on yours. Oops, it's not on. 1,400 times 5 is 7,000. So negative 7,000 plus 28,000. Well, 8,000 minus 7,000 is 1,000. So I might have 21,000. Okay, and that has meaning on the graph. That's 21,000 gallons at 5 minutes. So that's what that means. In 5 minutes, her water level is down to 21,000 gallons. Now, a lot of you noticed yesterday that where they cross looks like it's at 10 minutes. And we were debating, well, what is that? Is that 16,000? Is that 12,000? Looks like maybe it's halfway in between. And we can use the same tool to figure that out. So let's figure out what A of 10 is and what D of 10 is. If they come out to be the same, then we know that we did it right. So I'm going to do that on where we have plenty of room. All right. And this is number 7 for reference. array of 10 equals negative 1400 times 10, times 10, and we're adding the original amount of gallons, okay? And multiplying by 10 just means we're going to have one more zero, so it's going to be 14,000 this time. Negative times a positive is a negative. Be careful with your signs. All right, that's easy because 2 minus 1 is 1 and 8 minus 4 is 4. So 28 minus 14 is 14. So the answer is going to be positive 14,000. And that's gallons at 10 minutes. So let's make sure that's the same. We think it is, but we can double check. So if you remember what your rule was for Dane, his pool drains slower, only 1,000 gallons a minute. Still talking about 10 minutes. And he had less water. Right? All right, so you can figure that out. You don't have to wait for me. Multiplying by 10 is easy. Okay, however many zeros, just put extra one on them. Plus 24,000. And 24 minus 10, 2 minus 1 is 14. It's going to be positive because we have hooray. So what does that mean? That means both Dane and Allie have 14,000 gallons left to drain at 10 minutes. All right. Now, this is a lot of work. You may be getting a little frustrated. It's a lot of different things that the book is wanting us to use this information. The book is wanting us to put together a lot of things we already know how to do and use them based on a pretty simple situation that we can pretty easily understand. Water draining out of a pool, water getting pumped out of a pool at 2 different rates. And interestingly enough, there are many, many situations where things are happening at 2 different rates, and at some point they cross and become exactly the same, and then they go on and change again. And so the other idea that it was asking us about is what does it mean when one graph is above the other? And what does it mean in the pool when one graph is above the other? What does it mean in the pool when one graph is below the other? What does it mean about the water? All right, so I know this is a lot. So I'm going to pause right there.